Alright, so to start off, implement some of the strategies that we've already discussed for solving some rational equations to solve here for the variable x, and then prove that the answer you get is in fact a solution for this equation, for each equation. Okay, so starting with number 1, you'll notice a couple of things. The first is that I have two rational expressions here. They have the same denominator, so I can subtract them without a whole lot of extra work. And I'll have x minus 2 over 5 equals 1 over 5. Now at this point, you probably want to get rid of any denominators, so you'll multiply by 5 on both sides. That will leave you with x minus 2 equals 1, which you can solve very simply to tell you that x must be equal to 3. Now, before we go any further with checking this answer, let's just take a look at why this worked out so nicely. If we back up to the step at which we multiplied by the denominator, you'll notice that the denominators were the same, so that when I multiplied by one of the denominators on both sides, both denominators went away. And in essence, all I was doing was looking at what would make the numerators equal. Since the denominators were already the same, that should be pretty obvious. What will be equal to 1/5? Well, 3 minus 2 over 5, obviously. And so this is a strategy that we can implement whenever we can get a common denominator amongst all of our rational expressions. All we ended up doing is saying, since we have x fifths minus 2 fifths, and that has to equal 1/5, then x must be 3, since 3 fifths minus 2 fifths will equal 1/5. Alright, at this point, let's go ahead and prove that our answer works. How will we do that? Well, we can take our value of x, go back to our original function, and substituting x with 3, we can check that the equation works out. And once we do that, the work is pretty simple to show that the left side of our equation equals 1/5, as does the right side. Alright, let's take a look at number 2. When I take a look at this particular problem, I notice that I have a variable in the denominator, and I also have a rational expression here. So in order to get my denominators out of the way, I can multiply on both sides of my equation by both denominators. Once I do this, I have to make sure that I do two things. The first is that I correctly cancel out anything that goes to 1, x plus 2 over x plus 2, and 4 over 4, simplify to 1. And then I have to remember that I'm distributing, because I'm multiplying 4 by this whole left side, I have to multiply 4 by all of x minus 1. And I have to multiply x plus 2, all of that, by 3. Once I have this situation here, I can see that I'm solving for x, and so I want to collect all of my x values onto one side of my equal sign, and then isolate. Distributing in and then performing the correct inverse operation allows me to collect x equals 10, as you can see here. Last but not least, I want to check that my solution works with my original equation. So to prove this, I simply substitute my value of 10 back into my equation for x, my original equation. This will give me 10 minus 1 divided by 10 plus 2, which is 9 over 12, equals 3/4. And I don't have to do anything else here. 9/12 is equivalent to 3/4. They are equivalent fractions. Alright, so at this point, let's go ahead and capture some of the key points that we've discovered. Alright, so a couple of key points that we can add on for solving rational equations. The first is what we noticed in the first problem, is that if we have a common denominator for all the rational expressions in our equation, then we can solve the equation for the numerators. The only thing that we need to make sure are equal are the equation in terms of the numerators. Also, we can confirm the solution by substituting back into our original equation. So these are things we want to utilize to A, make our solving process more efficient, and also to check that our solution is correct. So let's go ahead and apply these a couple of times. So try this first on your own, perhaps go back and look at those key points to determine a method that might be advantageous here. there are probably a couple things that come to mind, and they're very similar. You could combine these rational expressions by adding, and in doing so, you would then end up with a denominator of 6. But that will also make all of these rational expressions have the same denominator. So it might make sense to just have all the denominators become the same, and then you'll be able to solve this equation just for the numerators. So let's go ahead and do that. Okay, now that we have a common denominator across all of our rational expressions, we realize that we just need to be able to make sure that 3x plus 2 is equal to 5, because since this is a common denominator, this is 3x plus 2 sixths. That makes our problem-solving process much easier. I can now isolate x with only 2 operations, subtracting 2 and dividing by 3 from both sides. All right, and once we do that, we solve for x and we end up with 1, and now we'd like to prove that our solution is valid, so we'll go back to the original equation and check out whether or not x equals 1 will work. So in doing that, we end up with 1/2 plus 1/3 equals 5/6, and I'll need a common denominator to add my 2 fractions, and when I get a common denominator of 6, I'll end up with 3/6 plus 2/6, which sure enough is 5/6. And you can really see in this checking how all we had to do was make a common denominator, and once we did that, all we had to worry about were the numerators in the equation fulfilling the equation. So 3 plus 2 must equal 5. And perhaps when you did that, you noticed that, or at the beginning, you noticed there was another way to do this, where you could simply subtract 1/3 from both sides as your first step, and then multiply by 2. And similarly, that would have gotten you a correct answer of x equals 1. All right, in preparation for class tomorrow, go ahead and work through 2 and 3. Make sure you're utilizing some of the strategies that we've discussed either today or previously. And if you have questions about how you might apply some of those strategies, make sure you write them out so you can discuss them at the beginning of class.